All right, guys, welcome back. Module 2, Lesson 9. So here's what we're going to be doing at the very end of this problem set, is that you're going to be fluently multiplying that whole digit numbers to solve word problems. Remember, fluently means to be able to follow the steps in an organized way, look for patterns, look for shortcuts, and be able to keep everything nice and neat when we do standard algorithm. That's our focus, to multiply using standard algorithm. So let's get started with the first problem. All right, question number 3 says Peng bought 26 treadmills for her new fitness center at $1,334 each. Then she bought 19 stationary bikes for $749 each. They want to know how much money did she spend on her new equipment. They want us to write an expression. That means write the problem, and then they want us to solve. So we're going to set up the problem, how would we figure it out, and then solve to find the actual answer. So we're going to start by saying, okay, if she's getting treadmills, she's getting 26 of them, and then each of them is $1,334. So we would multiply that first. And then we would take the 19 bikes that she wanted to buy and then figure out that each bike is $749. So those are the bikes. And then to figure out how much she spent altogether, we would then just add those numbers together. So this is our expression. Remember, expression is just the problem without an actual answer. So let's go ahead and solve. Okay, 1,334 multiplied by 26. 26 tells you there's going to be two partial products. So that gives us a good little roadmap. So 6 times 4, that's 24. I'll do that in blue. So 4 goes down, 2 comes up. Then we have 6 times 3, that's 18, plus 2 more, that will give us 20. So carry the 2, bring down the 0. Now we're going to do 6 times 3 again. That's 18, plus 2 more would be 20. So you're going to write your 2, and then bring down your 0 in the hundreds. 6 times 1,000, that would be 6, plus 2 more would be 8. So we have 8,400 in the first partial product. I'm done multiplying by the 1s and 26, taking all the numbers up on top away, or just crossing them off. 0 placeholder, I'm starting in the 10s. 2 times 4, that's 8. 2 times 3, that's 6. 2 times 3 again, that's 6. 2 times 1, that is 2. Adding those together, I get 4, 8, 6. 8 plus 6 is 14. Carry your 1 to the thousand or 10,000s, and then 2 plus 1 is 3. So the treadmills cost $34,000 or $34,684. And now we're going to go ahead and do the next problem for the stationary bikes. We have 749, and we're going to multiply it by 19. 19 has 2 digits, so that means we'll have 2 partial products. 9 times 9, hopefully you know that is 81, so take down your 1 and bring up your 8. 9 times 4, that is 36, and then you're going to add 8 more. That's 44. Carry your 4 on top, bring down the other 4. 9 times 7, that's 63, times, or add 4 more, that would be 67. All right, now we're crossing off the 1s and 19, crossing the numbers off up on top. Going to the 10s, so there's only 1 10, so 0 placeholder, and then multiplying the 1 3 times, should be easy. 1 times 9 is 9, 1 times 4 is 4, 1 times 7 is 7. Adding those up, I would get 1. 4 plus 9 is 13, so 3 comes down, regroup the 1. And then 7 plus 4, that would be 11, plus 1 more would be 12. So bring down your 2, carrier 1. 6 plus 7, 13, plus 1 more is 14. So the stationary bags cost $14,231. So that means I need to take my two amounts, 34,684, add it to 14,231. So now I'm going to add carefully. 4 plus 1 is 5. 8 plus 3 is 11. 2 plus 6 is 8, plus 1 more is 9. 4 plus 4 is 8, and then 3 plus 1 is 4. So altogether on her new equipment, she spends $48,915. So let's write our sentence out. All right, so your sentence should say something similar to spent $48,915 on her new equipment. Ending punctuation should be a period. So here's our sentence. Remember again, if I go too fast, pause it, rewind if you need to, so that you're not falling behind. All right, let's look at number 4 here. We got a Hudson Valley farmer has 26 employees. He pays each employee $410 per week. After paying his workers for 1 week, the farmer has $162 left in his bank account. How much money did he have at first? So there's that word first. That means how much money did he start with before paying his employees. So if we do a short little tape diagram, and you're going to kind of just model the thinking that this is how much he paid, and this is how much he had left, and then up on top is how much he had at first, which we don't know. That's what we're trying to find out. So I'm going to write the word first and then put a little question mark because we don't know how much yet. But we can fill in the rest of the tape diagram. How much did he pay? We don't know exactly the price yet, but we do know that if he has 26 employees and each employee gets paid $410 per week, we can figure that out. And we do know that he has $162 left. So once we figure this out, we're going to add it to 162, and that's going to tell us how much he started off with. So let's go ahead and I'm going to do 410, and I'm going to multiply it by 26 because 26 has 2 digits, and I'd rather do 2 partial products than 3 partial products. So 6 times 0 is 0. 6 times 1 is 6, and 6 times 4 is 24. There's my first partial product, crossing off the 6 ones. There's no numbers on top to cross off, so that means I'm ready to do the tenths. So I'm going to put a 0 placeholder. 2 times 0 is 0, 2 times 1 is 2, and 2 times 4 is 8. So my 2 partial products, add those up quickly. This one should be fairly easy to add up. So I have $10,660 that he paid his employees. So we're going to take that amount and that we're going to now add it to 162. And that's going to tell us how much money he had before spending or paying his employees. So 6 plus 6 is 12. And then in the hundreds, 1 plus 6 is 7, plus 1 more is 8. And then the 10, there's nothing to add it with. So he had $10,822 at first before paying his employees. All right, so there's your sentence right there. A farmer, or the farmer, had $10,822 at first before paying his employees. All right, so question number 5 says Francis is sewing a border around 2 rectangular tablecloths. Okay, so 2 rectangular tablecloths. Now each of those two tablecloths measures 9 feet by 6 feet wide. 9 feet long by 6 feet wide. Okay, so before we move on, I'm going to visualize this. So if I have 2 rectangular tablecloths. Let's pretend I'm drawing the tablecloths right here. And they are 9 feet long and they're 6 feet wide. Please copy this down. This is going to help us visualize what to do. And I'm writing down the second tablecloth, the same thing. And actually, I'm going to go ahead and fill in the rest of the picture, because since it's a rectangle, opposite sides of a rectangle are equal length. You can't have one side be a different measure than the other and call it a rectangle. All right, so here is all of our measurements, and we have 2 because it says 2 rectangular tablecloths, and they're feet. Okay. Now the next part of the question gets a little tricky, so we got to kind of read it slowly. If it takes her 3 minutes to sew on 1 inch border, okay, so now we're talking about an inch border. To do an inch, it takes her 3 minutes to sew. They want us to know, or they want us to figure out how many minutes will it take to complete her sewing project. They want us to write an expression. All right, so what we're trying to do is, since she's doing a border, we're only looking at the perimeter of each rectangular tablecloth. So we're not looking at the space in between. We're just figuring out how long it would take her to sew around both tablecloths. And now this is all feet. And then she's talking about she can sew for every 3 minutes, she would sew 1 inch. So we kind of have to think this out. This is going to be a little difficult, but I know we can kind of push ourselves through. Now let's figure out, how would we find out what the perimeter of 1 tablecloth would be? That would be taking each measurement and adding them together. So we would do 9 plus 6 plus 9 plus 6. So that would be the perimeter of just 1 tablecloth. But if we had to figure out the perimeter of 2 tablecloths, we could continue to do 9 plus 6 plus 9 plus 6 again, but a shortcut would be, okay, let's add these up together and then let's multiply it by 2. And that would give us how many feet in both tablecloths she would have to sew around. But she says, or it takes her 3 minutes to do 1 inch. Well, how many inches are in a foot? That would be 12 inches. So once we figure out how many feet, because this right here is feet, and we times it by 2, it's going to give us still feet. That means we're going to have to go ahead and multiply it by 12 to figure out how many inches. And once we figure out how many inches, then we have to then multiply it by the 3 minutes it takes for every inch that she sews. So here is our expression. It looks kind of complicated, but I think we can kind of break it down quickly to help us solve. All right. So let's look at 9 plus 6 plus 9 plus 6. So if you know that 9 plus 6 is 15, and this 9 plus 6 is 15, that means 15 plus 15 is 30. And now what we're going to do is I'm going to rewrite the times 2 times 12 times 3. So now what we can do is, we know that 30 times 2, or 30 doubled, would be 60. So it would be 60 times 12 times 3. That would be the next step. Okay, well now what we can do here, now let's go to 60 times 12, because what we could probably do is we can take 6 and we can multiply it by 12, kind of off to the side, if you don't know what 6 times 12 is. So if I quickly do 12 times 6, that would give me 72. So that means 60 times 12 would be 720. and then I can multiply it by the 3 minutes, so that this represents 720 inches. This represents 60 feet. So this is my inches, 720, and you times it by 3. Well, we can quickly figure out, okay, 72 times 3 off to the side. I can do 72 times 3. That way 3 times 2 is 6, and then 7 times 3 is 21. So 720 times 3 would be 216, and add the 0 to give you 2,160. So this is now minutes it takes her to complete the sewing project. So I kind of ran out of room for my sentence by squeezing it in, and if you don't have any room, maybe down here at the bottom of your page, you can squeeze it in, or somewhere nice and neat. Answering the question, you can state or say, it will take her 2,160 minutes, make sure the word minutes, because that's the question, how many minutes, to complete the sewing project. And the final problem of this lesson, each grade level at Hooperville schools has 298 students. If there are 13 grade levels, how many students attend Hooperville schools? Some of you are like, well, I thought the last grade is 12th grade in school. How there can be 13 grade levels? Well, don't forget kindergarten is counted as the 13th grade level. So when you're a senior, you technically have been in school for 13 years. So we want to know how many students attend Hooperville schools. So we're going to take our 298 and we're multiplying it by 13. So we have 8 times 3, or 3 times 8, that's 24. And 3 times 9, that's 27, plus 2 more is 29. 3 times 2 is 6, plus that 2 more is 8. And now I'm done multiplying by the ones, and I'm going to go ahead and do my 0 placeholder, and I'm going to start in the tens. And good thing, I'm multiplying by 110, so that means all the numbers in 298 are going to be the same, because anything times 1 is the same number. So I have 2,980. Add those together. I get 4 in the ones. 9 plus 8 is 17. And then 8 plus 9 is 17, plus 1 more is 18. And carry my 1 in the thousands. 2 plus 1 is 3. So there are, and I'll write this one out since I have so much space. We're going to write 3,874 students attend Hooperville schools. Ending punctuation mark. All right, so now moving down to part B, it says a nearby district, Wilmington, is much larger. They have 12 times as many students than, I guess, Hooperville. How many students attend schools in Wilmington? So they have 12 times as many students. So if Hooperville has 3,874, that means we're going to take that and times it by 12 to get our answer. So 3,874, and we're going to multiply that by 12. 12 has 2 digits, so there's going to be 2 partial products. So 2 times 4 is 8, 2 times 7 is 14, carry the 1, bring down the 4. 2 times 8 is 16, plus 1 more is 17, and then 2 times 3 is 6, plus 1 more is 7. I'm done multiplying by the 1s in the 12, crossing my numbers off. I need a 0 placeholder. And I have a 1 in the 10, so it's going to be nice and easy to do. 4 times 1 is 4, 1 times 7 is 7, 1 times 8 is 8, and 1 times 3 is 3. Add those together. I get 8, 7 plus 7 is 14. 7 plus 8 is 15, plus 1 more is 16. Carry the 1 to the 10,000s. And 3 plus 1 is 4. So we get 46,488. So our sentence would be 46,488 students attend schools in Wilmington. All right, and ending punctuation. All right, so good job on solving these, some of these problems that are a little bit more complex and require more steps. We are done with the multiplying whole numbers. We're going to go over and practice multiplying decimals now, but something that we don't want to lose skill is multiplying these numbers fluently. We're not going to forget about this because this is going to be a 5th grade focus that we're going to be doing this whole entire year. All right, so good job on this lesson, and I'll see you on lesson number 10.